Thanks everyone for coming. My name is Zoltán Egyed from the local Hungarian Innovators Club. We are a local non-political organization for people of all kinds involved in innovation. We usually have one presentation a month, sometimes more. And today we will have David Kutas, who will present about his research in visual interfaces. A couple of things about just the logistics. During the talk, I will be muting everybody. After the talk, when there will be time for questions, please remember to unmute yourself. I can mute you, but I cannot unmute you. With that, please help me to welcome David Kutas.
Yeah, so hello everyone. My name is David Kutas. I'm a PhD candidate in the intersection of software engineering and human-computer interaction at the University of California, Irvine. I'm in my fourth year of the PhD studies, and I recently advanced to candidacy, which means that I just have a couple of steps left in order to finish the program. I'm originally from Hungary. I was born and raised in Hungary, actually in Miskolc in Borsod-Abaúj-Zemplén megye. And then I attended college there for 4 years. After that, I got a scholarship to study in Austria. So I was there for 2 years. After that, I moved to Germany, Netherlands, Norway, and Argentina to work for an international oil and gas company. I was a drilling data engineer. And then, so in the last, I would say 10 to 15 years, I was fully immersed into dealing with data and how we can leverage the data in order to like show it to people in meaningful ways. And then, so during my graduate studies in Austria, I was particularly involved in working for a company that was doing data interpretation for 10 to thousands of hertz data points that were coming in, and then I was tasked in order to like interpret that data and get useful information out of it. And then so basically, and I have also been always interested in software engineering, so I was doing it at home at my own. And then after that, I realized that this field is emerging and it's really important and really interesting. And then why don't I try to do a PhD in the same field? So basically in the intersection of data and visual communications. And that's the reason why I actually started the PhD studies at UC Irvine. And without further ado, I would just turn into my lecture, or like this little presentation that I have here, which is about user interfaces. And then I really wouldn't like to go into depths why user interfaces, why they are so important, or like I'm actually going to explain all those kind of things, but I just really would like to walk down memory lane and explain like what happened in the past, what is happening currently, and what is going to happen in the future. I'm not really going to focus on actual products or companies that are using using these user interfaces for building their ventures, but of course, like I'm going to walk into some of those a little bit. So if you have any questions, just during the talk, just please stop me, or otherwise we can just like have a conversation about if you have any questions at the end of the talk. So um, so why is this topic so important of user interfaces and user experience? So there is a researcher, Brad Myers, and then in 1998, before the merge of the mainstream internet and also the mobile phones, he was saying that user interfaces are likely to be one of the main value-added competitive advantages of the future as both hardware and basic software become commodities. So basically, what he's saying here is that you can have a wonderful product that has a great hardware architecture, or it's like working great for scientists with specialized needs. But if you don't have a persuasive user interface that would actually make it usable for layman, for everyone out there on the street, you're not going to make it. And then so actually why user interfaces are so important is because that's what makes the data interesting and usable for people. And so I think this is like a really good quote why this field is so important, and that's why we need to focus on these. So here's a timeline of what happened so far. It's like a broad overview of like what happened so far in the industry and where are we heading at the moment. And then there's a lot of speculation happening right around that red vertical line that I have on the screen. So we are going to talk about those as well, but it's probably not going to be as clear as what happened in the past. So let me just start in the 50s. So basically in the 1950s, after the Second World War, the US needed to leverage the benefits and the values that were coming out of the Second World War and winning basically the Second World War. So they needed to use the immense intellectual capital in order to actually propel the commercial avenues of the society. And then so basically, computers were emerging at that time, and then the first and people needed a way in order to interact with these computers. And then the first solutions that were coming out of that was the text editing command line interface. We usually call it TUIs. And then also the hypertext emerged. What is important about these research ideas and research avenues that actually all of these were started by universities or research centers around universities in the 50s. And then once they started to emerge, and then once like this proper of science started to grow, that's when commercial companies like, for instance, Xerox is started to come into the picture. So actually, everything starts with the university research because they have the basis of conducting such base research. And then when companies realize that there is probably values that we could take out of that, that's when they start investing into those. So that's what we are going to see um, throughout history here. So basically, we started with text editing with the command line interface in the 1950s, and then in the 1960s, direct manipulation and graphical objects started to emerge as well. That further helped to describe how computers work. And then also input and output devices started to emerge. So like 2D monitors, the mouse, and gesture recognitions as well. So here again, the research were either funded by um, US military or by NASA or by universities. And then there was like a huge deal. I mean, for us, it's still a huge deal that Douglas Engelbart from the Stanford Research Institute introduced the mouse and the first graphical user interface. We call it the mother of all demos. I'm going to talk about that later. And in 1973, Xerox, the company that produces copy machines, basically they had a research institute, and they still have a research institute in Palo Alto, and they produced the first, let's say, an idea of a commercial product like a personal computer that they called the Xerox Alto. And then many of the things that we see today, even today, in our mainstream computers, started to get represented. So that's when, for instance, the desktop metaphor came into the picture. But I'm going to introduce this in detail. I'm just walking through the timeline. And then in 1986, a researcher called George Furness came up with the idea of fisheye-based views and interfaces. And that's started to bring the field of physics-based user interfaces into the picture. And that was a very important step. The next step basically happened in 1993 with Ken Perlin from New York University by producing the PAT system. That was the first zoomable user interface. And then some quiet work happened throughout the next decade when the internet was in developing basically into the mainstream. And then we started the multi-screen world with the iPhone, with the first representation of the iPhone. Basically, there were devices before that, but when the mainstream started to actually embrace that mobile phones can be as good as a personal computer, that was started around 2007. In 2012, um, we started to go into a field where design systems and UI building frameworks started to get represented. This is a little abstract, so I'm going to talk about that as well later in detail. And then in around 2016, the augmented reality, virtual reality, mixed or merged realities started to get to reach a point where it's actually being useful for people. And then today we are in 2022, and then we don't really know what the future holds. We do see that AR, VR, and merged reality will have relevance in the future, as well as the 2D user interfaces that we already have today, just in some more modern and more fashionable representation, I would say. And then, of course, there are still debates that holograms and particle manipulation will be a big thing moving forward. So with this one, I would like to go back to the beginning of my timeline and then start with the 1950s again, just in detail. So the command line interface, right, what you see on the screen is basically was the way how people interacted with computers. So this is the command line interface. There's no graphical objects like icons, colors, or symbols, or any kind of things that would actually help people to understand the abstractions of the computers. The primary way how you were interacting with the computer was through predefined comments that the programmers were providing to people. So for instance, if you wanted to go to another library or like another folder on your computer, you had to like type in cd dot dot, and then it jumped out, and then you could uh, type in ls, meaning like list the folders in that given um, um, directory. And then basically, if you wanted to change again to another folder, you had to type in cd, meaning change directory, and specify the name of the directory where you wanted to go. And then this solution was awesome because this really helped people to start up interacting with computers. But nevertheless, this was not really good for the mainstream. This was really good for people who had the way of abstracting away complex information in their head, and then they were also able to learn these commands, and so they were using it for mostly for work purposes. So if you needed to calculate something, then you did this, but it was not useful for people who just wanted to like casually use a computer. And so this was the main limitation of the system. And of course, like they wanted to find other ways to actually interact with computers. And around 1965, and then of course the research started earlier. This was the maturation or the representation of that research that went into this. A researcher called Douglas Engelbart came up with this way of interacting with computers through graphical objects instead of using primarily text. And then in order to do that, a lot of inventions came into the picture. So for instance, graphical objects were represented as lists, as we can see here on the left-hand side. And then the first version of the mouse, a direct manipulation device, came up. So as you can see, there is a way to track the vertical movement of the mouse. And there is like, from this perspective, you cannot see, but there is another disk that is heading into the X direction. So in order to do that on a 2D interface, like this mouse was able to move to the left and the right. And then this is the connector of the mouse, which is awfully similar to what we were actually using like 20 years ago. So, and this already happened in 1965. And so this was a major step forward in computing. You can find a lot of videos about this on YouTube if you type in the mother of all demos, because this was also the first demo where actually a researcher stepped out and showed the world that like what we are capable of, and then how the future is going to look like. Of course, like this looked unbelievable. Even today, if you look up the video, it is going to look like something that could happen like 20 years ago, but actually it was like 50 years ago or 60 years ago. So this was a major step forward. And then the next major step was the Xerox Alto, which was presenting a graphical user interface. The graphical user interface, as you can see it on the right-hand side of this, was presented on a vertical screen instead of a horizontal screen. And what you can see here is that a different information is laid out into different so-called windows. And then these windows were able to be overlapped with each other. And so if you wanted to focus on one object of interest, then you needed to bring that to the front by clicking on it, and it got represented on the front. And then this computer is also interesting from the perspective that it is very similar to a personal computer. And then this is the point where Steve Jobs also visited the Xerox Alto Research Center in Palo Alto and bought the license in order to use one, and in some ways, the ideas represented in Xerox Alto in their upcoming Apple Macintosh computer in 1984. And then, yes, even before that, there was the Apple Lisa, but when it reached the mainstream, that was 1984 with the Macintosh. But the predecessor of the Macintosh is really the Xerox Alto. And then in 1986, a researcher called George Furness came up with these ideas of fisheye views. So fisheye views are really interesting from the perspective of the development of user interfaces, because that was the first point where we really didn't, where researchers wanted to get away from this desktop metaphor that we have just seen with the different windows where you lay out things in folders, and they wanted to use data or like how geographic points are represented in our world. And then, according to the legendary story, the idea came from this New Yorker's magazine cover picture. So basically, what you can see here is how people in Manhattan imagine the world. So Manhattan is the ninth Ave, that's like probably the center of Manhattan. And then as you move to the peripheries of Manhattan, the understanding of those streets are decreasing, and then their importance is decreasing. So Chicago is like just a sign somewhere, and then Las Vegas and Los Angeles is just something really tiny at the at the corner of the screen, according to people in Manhattan. So it's not really like a proper representation of data, because of course, like Texas, Utah, Las Vegas, and all those count states are like way bigger. But of course, like from the perspective of a person who is living on the East Coast, is very different than to the person who is on the other end of the continent. And then this was the inspiration in order to create such an interface. And basically, that's what we use today, fisheye interfaces. So this is the interface of the Apple Watch, and that comes from 1986. So once something is the focal point of your screen, and when you zoom up, things fall to the peripheries, and then they're decreased in their sizes. and that's what we call a fisheye interface. I just wanted to step out a little bit from my timeline in order to show like these ideas that we have since the 1980s just come to the point in 2014 with the Apple Watch where they are started to get used in our mainstream world. But of course, I'm jumping back right now in time. And then based on the research from George Furness, Ken Perlin, a researcher from New York University, started to toy around the idea that fisheye interfaces, so physics and geographic-based interfaces, can be used in some other ways, or like some other variations of those ideas can be discovered. And then they came up with the idea that we could actually just zoom into objects of visual objects. And that's basically when the first zoomable user interface was, let's say, invented. So for instance, Ken Perlin came up with this idea that we have a calendar that is in years on the top left-hand side of the image. And once you click on the 1992, the year 1992, the entire user interface gets magnified with a 1-point perspective magnification. And then once you reach another level of zooming, then in that case, the months got represented. So January, February, March, April, and so on. And if you further click, then you reach another zooming level, and that's when you reach the days of a given month. So that was also a revolutionary idea, and then started to push also research and companies to accelerate hardware research, because you needed immense graphical power to power these animations and to make it useful for people. Because if you would just like jump from the 1992 into the bigger picture without animating between the views with the zooming effect, it probably wouldn't help. So so this is an interesting point where the research is pushing the hardware, and then hardware also pushing the software, and then this just continues until today. And then Ken Perlin didn't only focus just on zoomable user interfaces, but he of course like focused on fisheye as well. So what we can see here is that you can traverse through a set of folders and directories with a fisheye lens. And if you click on any of these objects, then you can change the focal point of the zoom. And that's how you can change the object of interest. And then basically what we see here on this very screen is that in 1996, there was Yahoo already as a website, and then it's a tab-based navigation between different web pages in an early browser, in an early web browser. And then I'm jumping out right now a little bit from my timeline, and I want to focus on graphical user interfaces, because even though those research ideas and then some things that were carried out later on into our mainstream user interfaces, the first one was the graphical user interface. And it still is a very important thing for our life, because that's what we face every day, basically. So this is the first version of Windows. That was just a shell over MS-DOS, so Microsoft DOS, the operating system that was based on the command line interface. This was in 1985, so this is just a screenshot from that one. So you can see that there's a clock, there are windows. So these are the windows marked with purple color. So this is the clock window first, MS-DOS executive, that's the second window, and the third window is here, the readme.doc. And then what is interesting here is that they didn't carry over the overlapping windows that we have already seen from Xerox Alto. And the reason why they didn't carry that over is because Steve Jobs and Apple had a license on that. And there was also a big lawsuit between the two companies at that time. And then Bill Gates was on the side of deciding not to carry over those ideas because that could hurt Microsoft. So this is, I believe, Windows 95. This is the point where I started to use computers when I was 4. And this was actually really, really good. At that time, you could already represent 60 million colors on the screen instead of only 256. And then the famous start menu was already developing. And this is the first point in history where these design system and system-based visual system-based thinking started to emerge. Why this is important is because once you have clues and practices that you build up in people, or like you help them to build up practices for themselves, like themselves, like for instance, where you are going to find your most important information, or where you start out interacting with the computer, that's where you like make it easy for people to actually do their daily work. And then this is the first representation of that design-based thinking. And then this is even true today. So these are the two latest versions, or I believe like one of the latest versions of Windows and Mac OS, probably the two most popular um, operating systems is user interfaces. So basically, we still got the start menu, and we have a very similar representation in Mac OS. We call it the dock, and they are awfully similar. Of course, they are influenced by each other throughout the years. So that's where we are. This is an interesting point to take a break here and to see that actually what we are using today as computers that we think that they are purely graphical user interfaces is not actually true. What we are using is hybrid user interfaces, because for instance, on Macintosh, if you hit the F3 button, then you are going to end up in a zoomable user interface where all the windows are laid out in this unorganized grid, and then you can switch between the windows and to change your focus of work. And so that's very interesting to see that it's actually happening, that more advanced physics-based interfaces, as I have already mentioned, are coming to life. And of course, I need to mention here one of the most famous zoomable user interfaces, that is Prezi, and it's a Hungarian company, and it's been immensely influential in the way of how visual thinking has been formed in the last 10 or 15 years. And the company is still progressing. They are building even more complex information visualization solutions. They also acquired some other companies in Europe, from Estonia, I believe, and they are making the next steps in information visualization and storytelling through zoomable user interfaces. And then in 2007, we actually entered the multiscreen world. And this is very important because all of those paradigms that we developed for larger screens and for a given aspect ratio, where you have like a wide screen instead of like a tall screen, even though there was the graphical user interface of the Alto, was questioned. Like, how do we build actually systems for these devices, user interfaces for these devices, in a way that they are going to be good for some other computers, so for some other classic computers, because these devices are smaller, these devices have different aspect ratios, screen aspect ratios, and also just you cannot be so precise with these devices, because you actually either need to use a stylus like a little pen, or you need to use your fingers in order to interact with the system. So this was a major point which triggered a lot of interaction. So let me go back. So this triggered a new wave of designers to come to the scene because we needed to solve like these problems. So, for instance, interaction designers came into the pictures, more graphic designers came into the picture, and so the whole industry started to expand. And that's what we actually see today, that we don't have a software engineer anymore who is able to design front end and back end systems from the database to the user interface, but these fields are being separated. So we have people who are designing user interfaces purely, and we have people who are actually designing, for instance, databases or machine learning algorithms in order to deal with data. And so the complexity of the industry is growing. And the next step, what we have is augmented reality. So virtual reality and mixed reality. Virtual reality is when we actually have like a device that we put onto our face, and it covers fully our eyesight, and then basically we can visualize any kind of information there. And through some other sensors, we are able to project some data onto it. And then once we are moving our head, the targets are moving there as well. Augmented reality is a little bit different. It's basically a way where we don't need to immerse ourselves into these environments fully, but we just add another layer of information to the real world. So, for instance, I believe the easiest way to understand it is like, for instance, when we are moving with Google Maps on a street, and then we don't really know that street, we can just hold up our phone and it will project another view, another layer onto the street through the camera, and then it will help us to understand which street we are on. And then merged reality is when the two systems are intervened. So you have a headset that you put onto your head. It fully covers your view, but through cameras that are outside the headset, project the real world into your view, into your virtual view, and it augments through the layers of that we also add in the system. So these are immensely complicated systems, and that's where real challenge is right now. Uh, for hardware designers, software designers as well, like how do we make this useful and usable for people? And then, of course, like Facebook was recently renamed, as you probably heard. The new name of the company is Meta. And then, so Meta is committed to this way of organizing information and creating products around these ideas. They already have a virtual reality headset. They call it the Oculus. They mostly use it for gaming. They also have an augmented reality headset. They um, collaborate with several companies. For instance, one of the companies that they collaborate with is Ray-Ban, the sunglass manufacturer. So they produce system for that one. And merged reality is happening right now. I believe that they have a new software that is good for virtual meetings, and that's how they are taking the next step in order to bring the human experience into the digital world. If it's good for us or bad, I'm not sure, but that's where we are heading. And the future is actually probably the past, because we have holography for like more than 100 years now. And then that comes from one of the Hungarian innovators, Gabor Dénes. And some technical difficulties are still there in order to have like larger projections with holography, but the benefits of holography are immense, because you don't need to put any bulky big glasses onto your head in order to have like an augmented experience that are programmatically created, like images of like animals. You can just see it with your eyes, or like that's a dream where we could head into the future. So that's a more humanistic experience compared to interacting through lenses that we put onto our heads. And then there is also particle manipulation, which is an abstract concept. It's not even a reality, and it's probably not going to be a reality for the next 100 years. But basically, what this idea is about is that basically there would be particles like little droplets of liquids or solid materials that could be programmed, and these molecules of solid or liquid particles could be moved to left and right to actually work together in order to create shapes. And then they could also change their colors and positions. So that's a very interesting idea. And then user interfaces today. So the status quo is that we use multiple devices in our daily life. We use computers, we use tablets, we use mobile devices. And so we call these multi-channeled and cross-media experiences. At the moment, there are no seamless experience exist connecting these platforms. So for instance, when you use a mobile phone, you actually need to learn like how this device works or how the user interface works. And when you go into use like a laptop, then you also have to learn like how that works. And that is taxing for your brain. We call it cognitive load. And in order to overcome these limitations, you need to act as a bridge connecting these devices. So that's what's hard for humans. And one of the ways to solve these one of the ways of solving these issues is actually the use of responsive design. This is a paradigm that was invented in 2009. As you can see, when the screen size is changing, the content on the interface can change according to the size of that window. This is just a very simple example of that one. And of course, design languages and systems started to emerge. So for instance, Google, Apple, Facebook, large tech corporations develop their own visual languages like colors, systems, buttons, shapes, and all sorts of stuff that make it somewhat easier for people to interact with their systems across devices. They also promote and release those components, these visual components, for free. And then they do this because they want to tie the developers of these interfaces into their systems. And then, of course, it has some actual net positive benefit is because these companies are highly professional. They know their ways, so they enforce best practices, so systems becomes more useful. One of these systems that you might see is Google Material Design. They have certain shapes, buttons, action colors, and it makes it easier for people to understand complex information. Microsoft has a similar system. They call it the Fluid Design System. This is just a screenshot of that one. And then we also have another layer of this that is a little more abstract and that we call frameworks and libraries. And then once you have these visual components, you also have to code them into your system. So they're like the actual visual elements have representation in code. And then these systems need to be created in order to be used. So for instance, React is one of the most famous one. Angular is another one by Google that is also very widely utilized. And then there are some open source libraries that are developed by people who don't want to commit to these large corporations. And then that is, for instance, Vue and Svelte. And previously, there was a popular system called jQuery. And then, for instance, this is React. Once you have a user interface element that is, for instance, this white frame, this is how you code it. You just specify that this is a section, and then you close the section here, and that's going to create this white box for you. Angular is very similar. It's yet another system, this framework, and it comes from Google. And what we can see in the last couple of years is that the interest to React is increasing. So for instance, this system really started around 2012, and now we are in 2022. And as you can see, the popularity of the usage of React has exploded almost unbelievably. It's almost dangerous to see like how popular React is compared to the other systems, because for instance, Angular, that is the um, um, that is a system that comes from another major tech corporation, Google, is barely making it here. And then Vue, that is an open source system, is barely able to keep up with the popularity of React. So we see a network effect here as well, that these systems are increasing. That React's importance is increasing so much, and we don't know what the future holds. But if there will be some market reorganizations, or like, for instance, Facebook, or now called Meta, is changing the ways like how they handle these systems, then it will be very interesting to see like how the world is going to react to that. So I also just very briefly wanted to touch upon my research. So my research is focusing on with the motivating question of like, how could human-computer interactions fundamentally be more unified? Like, how can we make it for people to use systems with less cognitive investment? So how can I make systems that are easy to use for people, and you don't have to think about how to use those systems? That's what my research is about. So for instance, here, I just want to describe the research that I've committed even before coming to California. So for instance, this is a tool that is widely used in the industry for project management. Basically, you have timelines here that has data about an organization's work, and then you have given tasks that people do in this company. So for instance, on May 1st, this person needs to reach out to potential guest speakers. So this is like a Gantt chart view. But once you want to interact with this system, you have to click on this object here, and then it navigates to a completely different view in order to see the data there and to interact with that data. And then there are some other views in order to interact with the data. And then I found this way of interacting with data very, very hard. Like, once you need to change the context of where you are, it's very easy to forget where you came from and what you need to focus on in the future. So the goals of my work is to develop user interface models that can be used to decrease this sight bridging, where you need to invest less into the cognitive understanding of like where you came from, where you're heading, and also to develop and test the first goal in a novel design productivity tool. So how could we recreate that productivity tool in a way that it would be easier to use for people? And then I just want to show that tool for a second. So here's a prototype of that tool. So very similar Gantt chart-based view that we have here. And if you click on that one, instead of navigating to a completely different view, you get the data right here with the zoomable user interface, and so on. So you can click into other objects and then interact with that data. And then you can navigate back and forth horizontally on those timelines instead of like navigating into different views of the software. So yeah, thank you so much for your attention. I hope you enjoyed it. And if you have any questions, please let me know. I stopped sharing my screen.
Thank you very much for your fascinating talk. And if you have a question, please remember to unmute yourself. Actually, as you are gathering your questions, I had one. You mentioned the merged reality, and that just sounded a little bit hazy to me. Would you have maybe an example of how that would look like, that I have an overlay, but also some kind of manipulating real objects? Would you have an example for that?
Oh, yeah. So I probably didn't describe that idea very well. So basically what we have here is, can you imagine like how virtual reality experiences work? Okay, so basically you put on this headset onto your head, and then some sort of like an interface is projected in front of your eyes. And then this mixed reality works in a way that on the headset, on the outside of your headset, there are cameras on the left-hand side and the right-hand side. So basically, your eyesight is extended beyond the headset. And then so those cameras pick up your environment. And then they are projecting the live stream of those cameras into the interface. And then they mix together the one that is coming from the software and then that is produced by the cameras. So the real world.
Understood. Thank you.
Yeah.
I really like the idea that the future is the present, or sorry, the past. You know, yeah. If you can elaborate on that, like how do you? Because there are a lot of patterns around it's, the technology that Gabo Dinesh invented. So I saw it working really well on the small scale, but like I don't know how it works, or can it be scaled up, and what are the bottlenecks and how they plan to overcome.
Yeah, could you please repeat your question, because I'm not sure that I was able to pick up your question because there was some echo. So
oh yeah, sorry about that. So I love the fact that you said that the future might be the past, and then we're going to use how do you call it? Sorry, it's skipping.
Holograms.
Yes, exactly. So but there were a lot of bottlenecks around scaling those systems up in the past. So how do you see those being overcome in the future?
Yeah, so basically the biggest problem with holograms, as far as I understand them, is that there are physical limitations of them. So the holograms exist when there's a reflective material, or where you project the light, and then there needs to be like some sort of a reflective material upon which the light is reflected back and refactored, and then you can see it with your eyes. And then basically it's like you still at the idea of like a screen, like a projector, where you project the light, and there needs to be some sort of a frame that picks up the light and then reflects it back to your eyes. And so that's the big problem with holograms, that's also very limited, in a sense that you need to create that frame. And then if you need to go bigger, then you need like a room which is like a size of a cinema, for instance, if you want to show like an elephant in its real size. And that's not really good. Then the problem, and then so that's why current research has started to deviate into these virtual reality headsets, because basically the projection is put onto your eyes, so you don't need to create that big reflective surface out in some sort of a bigger space, like for instance in the size of a cinema. So I think the real solution will not be holograms, but I think it will be like materials or particles that can be manipulated and then moved programmatically. How we are going to do that, I have no idea, but these nanomaterials that can be moved by some magnetic forces, for instance, that's a way ahead, I think, and that's very interesting.
So it's really interesting
Yeah, hologram.
to talk about hologram, right? Because Sony faced with the issue that the next generation of TVs will be holographic, and actually they went to really close by Hungary to do an experiment to do color holograms, because they have an issue to make them color. And as far as I know, that would be the next generation of TVs which are coming. Let's see.
Yeah, so that's also very interesting. And then we should not forget about that. Like around 10 years ago, there was a big push for 3D TVs, where you put up glass and then it brings up some layers from the information. I mean, some layers from the TV, and then it makes it like somewhat like 3D like. And then all those ideas actually flopped. Those ideas died, even though they were very popular at that one time, like 10 years ago. And I would say that for the next 20 to 25 years, these virtual reality solutions will be the things that we are going to do. Like we put on headsets, and that will produce like a complete world around us. But yeah, let's see. I do believe that Silicon Valley is going to produce the next big thing, and then it seems to be like the Silicon Valley companies are going into virtual reality. So I think that's what's going to move us forward. But I'm not sure that ultimately that's the way that would be good for humans, because I don't believe that putting a big headset onto your head is actually good for you.
Yeah. Just one more comment to the TV, the 3D TV. It died because you had to put a glass on.
Right. So I think that we
people
are
they
facing the
don't
same
like
issue.
to put a glass on. So if you need to put a glass on for VR too, yeah, maybe the hologram is the winner.
Yeah. So that I believe that like we're probably gonna go into that, because these headsets are going to be even more lightweight. They are going to be easier to be worn. The refresh frames will be, I mean, the number of refresh that the screens will produce will be better and better. So it's not going to be that tiresome for your eyes. And then at some point in the future, I also expect that they are not going to be bigger than sunglasses, like in the next 5 to 10 years. But in the same time, you still need to put on something to your eyes, and that's not what I want to sign up for.
Yeah, I remember watching 3D movies at Joe's house. He has a 3D TV.
Katalin has raised her hand.
Oh, David, you didn't mention the load on the hardware, that all these graphics and holographics, the amount of chip power that's needed. I mean, are we getting ahead with the software now? It used to be that we produced all the chips that you guys could use up, but now it looks like this is way ahead of what a standard chip can provide.
Yeah, so that's part of the thing, the issue that I'm dealing with. So for instance, in the systems that I produce, the issue is the software. It's not the hardware anymore, or so the thing what we are facing is that I think the hardware power is enough that we have at the moment, and it's still like seems to be that the Moore's law is somewhat able to be kept up. So I think that won't be an issue for the next 25 to 30 years. But the software is not able to produce like those frameworks that will be able to create these systems easily. So for instance, React is good to create 2D interfaces, but we don't have actually the frameworks that are making it easy for people to create 3D experiences. So for instance, Unity is there, or like the Unreal Engine is there to produce like these gaming-like experiences, and those are developing, but it's still not down at the level where like a developer, front-end developer could just like stand there for like 2 or 3 months, sit down, study it, and then use it. And so I don't think that the future will be about the hardware. It's more going to be like the problem will be around software.
And I see that Esther raised the hand.
Yes, hi. Back to the holograms. I have, you reminded me that it did not develop since the 90s or whenever I saw it first time in the museums, it just stayed. And I think every technology will develop if there is a need as an application, they can use it. And I thought that holograms or some kind of technology is used in a medical field, like it shows the doctors that there's the heart and you can reach in and this is how you operate or something. So is there any kind of, it's almost like sci-fi, maybe I saw it somewhere on TV, but there is something about the hologram that seems so magical and useful. And I'm surprised that they are not using it in some fields like, training things or like some kind of technology fields or medical field. Is there anything you know about that?
So for instance, yeah, I think it's a very good question. And then, for instance, in our department, there's an astrophysicist at the UC Irvine, and then he is using it to produce 3D projections of planetoids in order to see them, like how we could leverage the raw materials from those planetoids and like to get out the raw materials. But the big problem here with the holograms is I think they are stuck in the development. I mean, the way of like how holograms could be developed because of the physical limitations. So I think we need a technological breakthrough in how we could use holograms, or we could produce usable holograms. And it's not the use case. I think it's very easy to find useful use cases for holograms, because like everything what we see, like for instance in VR, could be replaced with holograms. But there is the physical limitations that we cannot project out light in a way where the light could be reflected where we want to. We always need like some physical substance where the light needs to come back from, and so it like produces sight for our eyes. And I have no idea what the solution will be there, but I think like someone will solve it.
Yosha, do you have another question or just left the hand up? Okay. So if we don't have more questions, I would like to thank you very much again for your great talk. And I would just like to give a reminder to everybody that the Hungarian Innovators Club is creating these monthly talks, and I encourage you to come to our website at hungariansv.com to see our upcoming events. And with that, I would like to pass the floor to our president, Csaba Szabó.
Well, I really enjoyed the presentation, and I apologize for being a couple of minutes late. I was just wrapping up a meeting. But these are the type of discussions I really enjoy, and that's the reason why we created the Hungarian Scientists in Silicon Valley about 4 years ago, and we keep running it so we can get to know each other, we can get to learn from each other. And just as a reminder, David is going to be in the Bay Area throughout the summer, so maybe that's going to be a good opportunity to have a follow-up. Maybe just meeting for a beer or dinner and talk about some of the other stuff that we didn't have the time and space to cover. Moving forward, we're gonna come back with some in-person events also as things are getting reset here in the Bay Area. So keep tuned for that. And our next presentation is going to be around biotech. So we're going to have a fascinating biotech entrepreneur lady based out of the Bay Area, who's doing some really cutting-edge research around genome work and CRISPR. So stay tuned for that, and more to come. And without any further ado, thank you so much, David. Please join me in a big round of applause.
Thank you, everyone. Thank you for the opportunity.